Today we're starting the last topic in our area unit, and this topic we'll spend a couple days on because there's kind of a lot going on. So today we're just going to be finding the area of certain types of regular polygons, and we'll finish the rest of them in the next lesson. So if we look at the example on the picture at the top here, we've got some stuff labeled, we got some colored lines drawn in. We need to kind of talk about everything that's happening in this picture. Now, the first thing to note, and this is what we're talking about today, this figure is a regular, so that's the big word for today. This one specifically is a regular hexagon. It's got 6 sides, call it a hexagon. Now, if you remember back to first semester, since this is regular, all of its sides and all of its angles are congruent. So that's what regular means. All the sides are the same length, all the angles at each point, those angles are the same. Okay, so we gotta recognize that. We're talking about regular polygons. Now, the middle of a polygon, so that dot in the middle there, we call that the center. Not too crazy. Notice that they've drawn in all of these blue little dashed lines, and all of the blue dotted lines represent a radius. That's what we call that, and a radius goes from the center to each vertice, or every point of my hexagon. That's a radius. So it's the distance from the center of the polygon to a vertice. And I'll put in parentheses to an angle, just one of the points, one of the angles of your hexagon. So you can draw in 6 little radius there. Now notice that there's a red dashed line right there, and that red dotted line, that's something like brand new, and it's a weird word, but that is called an apothem. Some people say apothem, it's called an apothem. Now, an apothem is a segment from the center, so they started in the center just like all the radii did, except this one, they dropped it straight down, so it's perpendicular and makes a right angle with one of the sides. Okay, so from the center to each point, each vertice, that's called a radius, but if you go from the center and drop it straight down to the middle of one of the sides, at a right angle, that's called the apothem. Okay, so note the difference between those two pieces. Also notice that an apothem and a radius, so if I kind of like piece all this together, an apothem and a radius together, along with, this will end up being half of a side, which we'll see in our first example, that forms a right triangle. And we're going to use these right triangles to figure out the area of these shapes. Okay, so that's kind of going over the different pieces that can be drawn in and what it means to be regular. We also need to talk about what's called a central angle. So in this same picture of this regular hexagon, angle 7 is called a central angle. It's one of the angles like in the center. Get my highlighter out here. All right, so it is formed by 2 radii. Be all fancy. Plural form of radius. So 2 little radii, the angle between them, angle 7, that's called a central angle. It's in the center. Now they want to know how many central angles are there in a hexagon. So each little radii, like we said, the angles between them, those are central angles. So there's 1, 2, 3, 4, 5. There's 6 of them. Which makes sense, you guys, because there are 6 sides on a hexagon, so there's 6 central angles. So if it's an octagon, there's 8 sides, 8 central angles. Now, if all of the central angles come together at one point, which they do, they all meet at the center here, then all of those angles, so they come together at one point, that means that they add to be 360. They kind of go full circle all together. Full circle is 360 degrees. Okay, so all the degrees in the center here around that are 360. So in a hexagon, the measure of each central angle, well, everything about this shape is regular or the same. So all 6 of these middle angles have to be the same. And if there's 360 total, you would just divide it, and each central angle would be 60 degrees. So that would make angle 7 60 degrees. If it was an octagon, well, there's 8 central angles, so you'd just do 360 divided by 8, and each one of those central angles would be 45 degrees. Okay, so kind of a lot going on so far. Last 2 things to note: the apothem cuts each central angle in half. Okay, so when they go in, and I know this whole angle right here is 60 degrees, because that's what each central angle is. When they draw the apothem in, they cut that 60 in half, and that would make angle 8 30 degrees. Half of your 60. All right, so that's a lot of information. All of that needs to be known, though, to find the area of one of these regular polygons. So let's kind of put it all together. The first example says, using triangles, which we've got a lot of triangles going on, I want to find the area of this regular hexagon. Leave my answer in simplest radical form. All right, so I'm going to use triangles, and looks like these dashed lines along with these 2 solid black lines, these are all radii. And this red line, that's the apothem from the center perpendicular to one of the sides. Okay, I'm going to focus my attention right here on this right triangle. The first thing that I'm going to do is I need to figure out what each central angle is. So there's 6 sides. So each of these angles here, just like the top example, all of those are 60. Remember, they told us when you draw the apothem in, you cut that in half. Okay, so this angle in my right triangle is 30 degrees. That makes this right triangle right here a 30, 60, 90. Which we know a lot about these, so we're going to have to use what we know to figure this out. I'm going to draw this triangle a little bit bigger just so you guys can see it. Okay, so I'm looking right here. Just going to draw a little bit bigger. Realize that when you drop the apothem in, it cuts the central angle in half and it cuts the side in half. So they're telling me from here to here is 10, so I know that this is 5. Okay, so I'm going to be able to work out the area of this triangle. I know I'm going to do 1/2 base times height. The short leg is 5, so the long leg would be 5 radical 3. Okay, so to find the area of just this one triangle right here, I would do 1/2 times the base times the height. It's not going to be that nice of a number. They want it in simplest radical, so do not put the radical 3 in your calculator. I'm just going to do 12.5 radical 3. Now realize that that is just the area of this one triangle right here. I want the area of the entire hexagon. So how many triangles are there that look like that in the whole shape? Well, there's 2 there, and actually there's going to be 2 per side, because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 of them. 2 per side, 6 sides. So if I multiply that by 12, same thing, don't put the radical 3 in your calculator. 12.5 times 12, 150 radical 3 centimeters squared. That would be the total area of the entire hexagon. All right, that's kind of a lot of steps. Is there an easier way? It's kind of the same amount of work, but there is an easier formula to think about, so that's what we're going to kind of discover right here. Remember that we did the area of one triangle. We did 1/2 times 5 times 5 radical 3. And then we multiplied that by 12 because there were 12 different triangles. And that's how we got our answer. Realize that you can recombine this multiplication in a different way. So, and this seems odd, but what I'm going to do is multiply this 12 and this 5, and I get 60. So I'm going to rewrite this multiplication as 1/2 times the 5 radical 3 times 60. Well, now they're asking, okay, well, what does the 60 actually represent? So if you look back at the picture, here's where the 60 comes from. It's the perimeter of the hexagon. Each side is 10, and there's 6 sides, so the perimeter is 60. That's actually what this represents here, which is kind of interesting. So instead of counting the triangles, you can kind of simplify your formula here for finding the area. And here's what it is. And this works for any regular polygon. So this is big. The area is 1/2 times, and notice where the height came from, 5 radical 3. That was the length of the apothem. So we're going to do 1/2 times the apothem times the perimeter of the shape. That's exactly the same thing as counting the triangles, finding the area of one, and then multiplying it all together. Okay, so here's how I'm going to talk about this. I'm going to say area equals 1/2 AP. 1/2 times the apothem times the perimeter. So we've got 3 more examples, and I'm going to show you using that formula how to find the area of each one of these. So the first thing you want to do is, well, I can find the perimeter, so let's kind of start up our formula. 1/2 times the apothem times the perimeter. This is regular because all the sides are the same. So the perimeter would just be 20 times 3, or 60. I just need the apothem. So let's draw the center in, and let's draw each radius in. Okay, you need to find each central angle. So there's 360 degrees around the center, and there's 3 central angles. So each one of these angles is 120. We need to draw the apothem in because that's what we have to find. So I'm going to draw it from the center straight down, and I'm going to use my right triangle right here to figure out, we'll call it A. When we dropped the apothem in, we split that 120, so that's 60 degrees right there in my right triangle. We also split each side in half, so that's 10. So I'm going to use my 30, 60, 90 rules. I have the long leg is 10. I need the short leg. It's the apothem. So remember that the short leg times radical 3 equals the long leg. So I want to divide by radical 3. And then I want to rationalize. So I'm going to times by radical 3 over radical 3. And I'm going to get 10 radical 3 over 3. That's my apothem. That is a disgusting number, but we're going to roll with it. Okay, so instead of counting my triangles, I'm going to do 1/2 times the apothem times the perimeter. Here's how you plug that in. Same idea, you just do not put the radical in your calculator. So I'm going to do 1/2 times 10/3 times 60. And that's 100. Stick a radical 3 on it. Meter squared. For the second example, so same thing, let's get my area formula going. 1/2 times the apothem times the perimeter. I don't know either number this time. That's unfortunate. I can draw in all the radii though. They're telling me each radii is 16, so I'm going to relabel that. I need to find the angles, so there's 4 sides, 4 central angles, each one's 90. We need to draw the apothem in, so let's drop that straight down. We've cut the 90 in half, making this 45. All right, I need this piece and this piece. I need both legs, which should be the same. So let's use our 45, 45, 90 rules. We'll call that A. Leg times radical 2 equals hypotenuse. Divide by radical 2, rationalize it out, and I get 16 radical 2 over 2, which would be 8 radical 2. Okay, so both legs are 8 radical 2. I know the apothem is 8 radical 2. I just need the perimeter. So let's use a different color here. I need one full side, so if half a side is 8 radical 2, multiply the 8 times 2. And one full side would be 16 radical 2. There's 4 sides, not 2 sides. There's 4 sides, so 64, stick a radical 2 on it, would be the perimeter. So that's what I'm going to use in my last set of parentheses here. Okay, super gross answer on this one. Leave the radicals out and do 1/2 times 8 times 64. That's 256. You can multiply the two radical numbers and say that that's radical 4. And radical 4 is just 2. So really my total area is 512. A lot of work, gross problem. All right, last example. So this one's a hexagon. They already drew in all the radii. I already have the apothem, so I'm going to do 1/2. Apothem's 10 radical 3. We just need the perimeter of this hexagon. So let's get our angles going. 360 divided by 6. Each one of these angles is 60. When they drew the apothem in right here, they cut that in half. So I'm looking at 30, 60, 90 when I look at my right triangle here. And we have the long leg is 10 radical 3. I'll call this x. I just need the short leg. So short leg times radical 3 equals long leg. Radical 3's are just going to cancel out. So x is 10. And you guys, that would make a full side 20. And then multiply it by 6, and you've got your perimeter is 120. And that's the last piece of information needed for the area. So again, in your calculator, don't put the square root 3 in there. Just put everything else. And then stick square root 3 on your 600. Don't know the units, so I'm just going to put units squared.